Three-phase power is a system that utilizes three alternating current, or AC, phases. These phases are displaced by 120 degrees from each other. Single-phase power, on the other hand, is a system with only one AC phase. Let's explore the advantages of each system. Three-phase systems offer several benefits. Firstly, power efficiency. Three-phase systems provide a more efficient transfer of power compared to single-phase systems. They generate fewer harmonics, which can cause heating and inefficiency in motors and transformers. Secondly, motor performance. Three-phase motors run more smoothly, have higher starting torque, and are more efficient than single-phase motors. Thirdly, reduced voltage drop. The balanced nature of three-phase systems reduces voltage drop over long distances compared to single-phase systems. Fourthly, increased power density. Three-phase equipment, such as transformers and motors, can be smaller and lighter than single-phase equivalents for the same power output. Fifthly, increased system reliability. If one of the three phases fails, the other two phases can still provide partial power, ensuring continuity of operation. Single-phase systems also have their own set of advantages. Firstly, simplicity. Single-phase systems are less complex to install and maintain compared to three-phase systems. Secondly, wide availability. Single-phase power is more widely available in residential and light commercial buildings. Thirdly, lower equipment cost. Single-phase equipment, such as motors and lighting, is generally less expensive than three-phase equivalents. Fourthly, compatibility with household appliances. Most household appliances are designed to operate on single-phase power. Here is the summary of the key differences between the two systems. For power efficiency, three-phase is higher, while single-phase is lower. Regarding motor performance, three-phase is better, while single-phase is good. For voltage drop, three-phase experiences lower voltage drop, while single-phase experiences high voltage drop. Concerning power density, three-phase offers higher power density, while single-phase offers lower power density. In terms of system reliability, three-phase is more reliable, while single-phase is less reliable. Regarding complexity, three-phase systems are more complex, while single-phase systems are simpler. For availability, three-phase is less widely available, while single-phase is more widely available. Considering equipment cost, three-phase equipment is more expensive, while single-phase equipment is less expensive. Finally, concerning appliance compatibility, three-phase is not compatible with some heavy machinery, while single-phase is compatible with most household appliances. The choice between three-phase and single-phase power depends on the specific needs of the application. For industrial and commercial applications requiring high power, efficiency, and reliability, three-phase power is recommended. For residential and light commercial applications where simplicity, cost, and compatibility are priorities, single-phase power is typically sufficient. Let's delve a little deeper into the technical aspects. Three-phase power, as mentioned, utilizes three AC phases. Each phase carries a voltage that alternates in a sinusoidal pattern. The key is that these three phases are offset from each other by 120 electrical degrees. This offset is crucial because it ensures a more constant and efficient power delivery. Imagine three people pushing a merry-go-round, each pushing at slightly different times. This coordinated effort keeps the merry-go-round spinning smoothly and efficiently. That's similar to how three-phase power works. In contrast, single-phase power is like having just one person pushing the merry-go-round. The power delivery is more pulsating and less consistent. This is why single-phase motors often require a capacitor to help them start and run smoothly. Now let's talk about harmonics. Harmonics are unwanted frequencies that can pollute the electrical system. They are typically generated by nonlinear loads, such as electronic devices and some types of lighting. These harmonics can cause a variety of problems, including overheating of equipment, increased energy consumption, and interference with sensitive electronic devices. Three-phase systems, due to their balanced nature, tend to generate fewer harmonics than single-phase systems. This is a significant advantage in industrial and commercial settings where there are often many non-linear loads. Voltage drop is another important consideration. Voltage drop is the reduction in voltage that occurs as electricity flows through a conductor. It's like water flowing through a pipe. The longer the pipe and the smaller the diameter, the more the water pressure drops. Similarly, the longer the electrical conductor and the smaller the wire gauge, the more the voltage drops. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. Three-phase systems, because of their balanced current flow, experience less voltage drop compared to single-phase systems for the same amount of power delivered. This is particularly important in long distribution runs. Power density refers to the amount of power that can be delivered per unit of volume or weight. Three-phase equipment, such as transformers and motors, typically have a higher power density than their single-phase counterparts. This means that for the same power output, a three-phase transformer or motor can be smaller and lighter than a single-phase unit. This can be a significant advantage in applications where space and weight are limited. System reliability is another key factor. In a three-phase system, if one of the phases fails, the other two phases can still provide partial power. This can help to maintain continuity of operation, preventing costly downtime. In a single-phase system, if the single phase fails, the entire system shuts down. Let's consider some practical examples. In a large manufacturing plant, three-phase power is essential for running heavy machinery such as motors, pumps, and compressors. These machines require a large amount of power and benefit from the efficiency and reliability of three-phase systems. In a typical home, single-phase power is sufficient for running most appliances such as refrigerators, washing machines, and televisions. These appliances do not require a large amount of power and are designed to operate on single-phase power. However, some larger appliances, such as air conditioners and electric stoves, may require a 240-volt single-phase circuit, which is essentially two phases of a 120-volt single-phase system combined. The National Electrical Code, or NEC, provides guidelines for the installation and wiring of both three-phase and single-phase systems. It's important to follow the NEC guidelines to ensure a safe and reliable electrical installation. For example, NEC Table 310.15b16 specifies the allowable ampacities of insulated conductors based on their size and insulation type. This table is used to determine the appropriate wire gauge for a given circuit to prevent overheating and fire hazards. When selecting between three-phase and single-phase power, it's important to consider the total power requirements of the application. Three-phase power is typically more economical for applications requiring more than a few kilowatts of power. Single-phase power is typically more economical for applications requiring less than a few kilowatts of power. It's also important to consider the availability of three-phase power. In some areas, three-phase power may not be readily available, or it may be more expensive to install. In these cases, single-phase power may be the only practical option. Finally, it's important to consult with a qualified electrical engineer or contractor to determine the best power system for your specific needs. They can assess your power requirements, evaluate the available options, and ensure that the installation is done safely and in accordance with all applicable codes and regulations. Now, let's discuss some of the common misconceptions about three-phase and single-phase power. One common misconception is that three-phase power is always better than single-phase power. This is not necessarily true. While three-phase power offers many advantages, it is not always the most practical or economical choice. Another common misconception is that single-phase power is only suitable for small loads. This is also not true. Single-phase power can be used to power a wide range of loads, including some relatively large appliances and equipment. Another thing to keep in mind is the different voltage configurations available for three-phase power. The most common configurations are 208 volts, 480 volts, and 277/480 volts. The 208 volts configuration is often used in commercial buildings for lighting and small power loads. The 480 volts configuration is often used in industrial facilities for running heavy machinery. The 277/480 volts configuration is a combination of both, with 277 volts used for lighting and 480 volts used for power. Single-phase power is typically available in two voltage configurations, 120 volts and 240 volts. The 120 volts configuration is used for most household outlets and small appliances. The 240 volts configuration is used for larger appliances such as air conditioners, electric stoves, and electric dryers. When working with electrical systems, it's crucial to always prioritize safety. Always to energize the circuit before working on any electrical components. Use properly insulated tools and equipment. Wear appropriate personal protective equipment such as safety glasses and gloves. And never work on electrical systems if you are not qualified to do so. If you are unsure about anything, consult with a qualified electrician. Understanding the differences between three-phase and single-phase power is essential for anyone working with electrical systems. By understanding the advantages and disadvantages of each system, you can make informed decisions about which system is best for your specific needs. And by following proper safety procedures, you can ensure a safe and reliable electrical installation. Furthermore, let's address the practical implications of harmonics in both systems. In a three-phase system, even harmonics tend to cancel out due to the 120-degree phase displacement, leading to a cleaner power supply with fewer distortions. In contrast, single-phase systems lack this inherent cancellation, making them more susceptible to harmonic distortion, especially with the proliferation of nonlinear loads such as LED lighting and variable frequency drives. Regarding power factor, three-phase systems generally have a better power factor than single-phase systems, which translates to greater efficiency and lower energy costs. Power factor is a measure of how effectively electrical power is being used. A power factor of 1 indicates that all of the electrical power is being used to do useful work, while a power factor of less than 1 indicates that some of the electrical power is being wasted. In single-phase systems, inductive loads such as motors and transformers can cause a significant reduction in power factor. Power factor correction capacitors can be used to improve the power factor in both three-phase and single-phase systems. In terms of grounding, both three-phase and single-phase systems require proper grounding to ensure safety and prevent electrical shock. The grounding system provides a low impedance path for fault current to flow back to the source, which causes the circuit breaker to trip and energize the circuit. The grounding system also helps to stabilize the voltage and reduce electrical noise. The NEC specifies the requirements for grounding electrical systems. These requirements include the size and type of grounding conductors, the location of grounding electrodes, and the bonding of metal enclosures and equipment. The voltage drop calculation is also different for three-phase and single-phase systems. The voltage drop in a single-phase circuit can be calculated using the following formula: voltage drop equals 2 times the current times the length of the conductor times the resistance per unit length divided by 1000. The voltage drop in a three-phase circuit can be calculated using the following formula: voltage drop equals the square root of 3 times the current times the length of the conductor times the resistance per unit length divided by 1000. The resistance per unit length depends on the size and type of conductor. Tables are available in the NEC that provide the resistance per unit length for various conductors. Finally, let's consider the impact of renewable energy sources on three-phase and single-phase systems. Solar panels and wind turbines typically generate direct current, or DC, electricity. This DC electricity must be converted to AC electricity using an inverter before it can be used to power AC loads or fed back into the grid. Inverters are available for both single-phase and three-phase systems. The choice of inverter depends on the size and type of renewable energy system and the electrical requirements of the load. In summary, the selection between three-phase and single-phase power hinges on various factors including power demands, efficiency considerations, cost constraints, and the intended application. Three-phase power is favored for industrial and commercial settings necessitating high power efficiency and consistent operation. Conversely, single-phase power is typically adequate for residential and light commercial purposes, prioritizing simplicity, affordability, and compatibility with common appliances. A comprehensive understanding of these distinctions enables informed decisions that optimize performance, minimize costs, and ensure dependable power distribution tailored to specific requirements. It is crucial to consult with qualified professionals to navigate the complexities of electrical systems and make informed decisions aligned with unique needs and circumstances.